So this is my attempt at Advent Calib 2025, day 4. I've already finished this. I'm having to re-record the audio, so we'll see how this goes. Had about an hour before I had to go to lunch. Took me about 35 minutes. So this is the puzzles. This year, it's about elves decorating the North Pole for Christmas. And this one is about rolls of toilet paper arranged in a grid. And the elves are having trouble, and they need to figure out which rolls they can access with a forklift. The @ symbol is the toilet paper, and the dots are empty spaces. This is our input right here. The forklifts can only access rolls if there are fewer than 4 rolls of paper in the 8 adjacent positions. So in a 3x3 area, we count how many toilet papers are in everything but the center. So this one has 1, 2, 3, 4, 5, 6, so it cannot be accessed. See, those X's are ones that can be removed. That top left one there has 3 that can be removed, so it can be removed, etc. So those 4 there can be removed because they have less than 4 neighbors. So part 1 here, we have to count the number of rolls that can be accessed with a forklift with all the rules as they are. Create a new folder for day 4 under 2025. Then I'll create a file for my main.go. So each one of these is like a separate runnable module. We'll copy the basic running code I had from the previous day. This uses my library AOC, which lets me handle these easily, read files from the same directory, etc. Create my part 1 function. Takes the contents of the file as a string, returns an interface, which can be anything in Go. Right now, I'm just going to tell it to return nil, let it be able to compile, and create the part 2. So this function takes the function that runs part 1 or part 2, a name to give it for the output, and the file for the input, which goes in the same directory. So now I'll create my sample.ioc and input.ioc files. Copy the sample text to sample.ioc. Go and get my puzzle input and save that as input.aoc. Get my expected 13 count for the sample. I don't know what the others are, so I'll report them as nil. Shows that local function. And since it's a grid, I have other helpful functions for processing grids. I call them areas. Let's see when we get there. There it is. Can get individual elements given a row and column, clone them, create new. There's a parser functions too. My local helper functions for automatically running, processing files, etc. Here's my parse area function. So I'm going to create a area variable and call it parse area to get the value given the contents that are passed. Think about how to handle this. Right now I'll say return nil. That'll just allow it to compile. And I'm just going to print out what the area is just to make sure it does what I think. And I'm going to import the format for that. And we'll debug and take a look at the variable. There's the files, these bytes, but those are the character codes. So width, height, or rows and columns, and then all the bytes. Okay, I'm going to create a helper function. So I'll give it a row and a column, and it will count how many neighbors there are. Call it count neighbors. Not super creative, but descriptive. Need to pass the area and the row and column I'm looking for the neighbors of. I wasn't sure if I used X or Y. It's been a year since I've used this library, but they're row and column. Oh yeah, I need to use the package name for that. And I'm just going to loop through the rows and columns. Actually, for the neighbors of the one, I'm going to go the row before to the row after, the column before to the column after. We need a count to add up as I check. See what's the method. Got the inside function to make sure I'm inside the grid, not out of bounds. And the is function will check for a character and return true if that's what it is. I'm going to return the count, which is an int. And I'm going to return -1 if it's not a row itself. So those blank spaces will return -1. I can tell that it's not a row at all. Check for the TP role character, and if it's not, return -1. And I'll leave count as -1, so I will count the one I'm on top of also. So basically this counts every toilet paper roll, and since I don't want the one I'm on, it's start at -1. And return the count. I'm going to make some tests just to make sure it's working how I expect. Just a file with _test. We'll create a test file and import the testing library and create a function I want to run as a test. I'll just copy signature from a previous one. Rename it. I'm going to start with Bill's Easy Sample Contents, just a 3x3. Need to check and make sure how to do multi-line string in Go. It is just the backticks will start one. A little variation in the spaces so I can check different scenarios. Need to import my AOC library to create the grid. Actually, I don't think I do need to do this. Oh yeah, I do, because I'm testing the function that takes an area. Copy the code that prints the error from my last test. And I'll create a helper function that runs the test and calls the error code if it fails. That way I can call it multiple times from my test count neighbors function. I'm going to call count neighbors with the data that's passed and check the expected value matches the value I got. Yeah, that uses the testing variable, so I'm going to have to pass that as well. Now I'm going to actually figure out what I want to check, and it'll be good for tests here. The top left one has two neighbors, the two below and below to the right. I notice here it's not shown up correctly. That's because the parse area returns a pointer to area. So that is mutable. I can change the values inside there. Okay, that passed. Let's write some more, check some more values there. Yeah, let's just check them all. Middle top one should be 5, left, right, and then 3 below. That one's not 3, it should be 2. It's the 2 below and below to the left. The left side should be 2. In the middle should be 5. Thinking about the counts, making sure 5 was correct for that. I think it is. Ah, no, it's empty, so I don't return the count of neighbors. I return -1. That's right. I think that one should be 3, the far right on the middle. Yeah. Okay, let's check that out. That passed. Alright. Let's actually try and run the test, see if it works. So I need to loop through all the rows. And loop through all the columns. Okay, we'll count the neighbors. The area, row, column. I'm going to have to keep track of the count, the total count that I can remove or access. So it has to be -1's invalid, because that would be no toilet paper there, and it has to be less than 4 neighbors. Then I increase the count and return that. So write a quick test for that part 1 function. Let's reuse the data from my check neighbors test. So 1, 2, 3, 4, 5. It should return 5 TP rolls with less than 4 neighbors. Don't need to create the area there because that part 1 function does it. I just need to check my value. My test data should be 5. Okay, run that. And that passed. All right, looking good. So we're going to debug the program. My launch profile is set up to run the active file in that case. Okay, we see I got 13. That's good. That's what we expect for the sample, and 1460 for the input data. Submit that, and it's right. All right, part 2. So if it can't be accessed by a forklift, it could be removed. Once it's removed, forklifts might be able to access more rolls of paper. They could also remove. So if I have the forklifts remove all the paper, they can in multiple iterations. So after you remove one, you need to be able to check and remove other ones as well. I think it wants to return, in the end, the total number that can be removed if we just let the forklift run until it can't remove anymore. Shows the highlighted in a lighter white ones that can be removed. They have less than 4 neighbors. And 13 of them could be removed this first without making any changes. Then once those 13 are removed, 12 more can be removed, etc. In the end, we get to a point where we can't remove any more, and there are 43 total that we removed. That's the answer I need to return. How many we can remove after going through multiple iterations, removing anything with less than 4 neighbors. Now it doesn't specify if you can remove one in the center. Here I spent a minute thinking about that. Like what if the entire grid has a border of 3 rolls of toilet paper and then a bunch of empty places in the center with a single roll. Can that single roll be removed? Wasn't sure about that. It's not specified in the test, so I'm just going to try it and see what happens. Okay, I need a function to change the grid so I can remove an actual roll of toilet paper. I'm going to copy the get and change it to a set at a byte ASCII value I can change it to. So area.getIndex expects the index into the old grid. You have to know what you're accessing the row column. So row call to index, I think, is a function I could call to get that. In that get function, I just calculate it. So I'll just calculate it again directly there. You check that I'm inside the box, inside the grid. Just return if I'm not. Otherwise, I get the index and just set the ASCII character at that index to the value that's passed. So I think I want a function to remove toilet paper rolls. Take an area. Usually put row and column, but thinking about it, how to return row and column, return a bool if we removed it or not, so we can count those up. But I think I'll just do the loop inside this function and return how many total I removed from the area. I'm thinking exactly what do I want to do. I could copy his way of doing it where I remove all the, or calculate all the ones that can be removed, move them all at once. But it really doesn't matter because I'm doing multiple iterations anyway, so I can modify it on the fly. It's never going to be a case where, oh, I removed one, now I need to check the next toilet paper roll as if that one were still there. Won't have to do that. It would help verify with the sample data if I did it that way. I could even put the X's in there and output them to the screen. Do an easy visual comparison with the sample. But wasn't really excited about that. Too much work. Just want to get it done. I need to maintain a count of how many I remove. I'll loop through the rows and columns again. I need to count the neighbors too, so I'll just copy that from part 1. And if it can't be removed, I'll just call the function to remove it. Return the count, how many I removed. Now to solve the puzzle, I just need to keep calling that remove TP function until it doesn't remove anything. I want to initialize my for loop with removing TP. How many I removed. Repeat as long as it's greater than or equal to 0, and I don't need to do anything at the end of the loop. Keep track of the total, so I'll just add the number removed to my total and return the total. I think I have to put that aside, but now I have the total variable. Now, maybe you spotted the error. I ran it and debugged it to find what I did wrong here. It's because the loop only sets removed in the initial condition. So it hangs and keeps calling the loop, calling the loop, calling the loop, adding to the total, but it's never updating and calling remove TP again. And we'll update this with the actual value. All that does is, you know, if you see the output there, it says bad because it was expecting nil. And that'll just show me that it's working right. And I get the number supposed to be removed from the sample part 2, 43. Put that there. Here I'm stopping it, trying to figure out what's going wrong. So one thing I don't like about Go is sometimes you get breaks inside the actual Go source code. I don't know where my actual program is stopping. Here I'm adding a breakpoint, run it again. Checking that remove TP function. Yep, that's right. First one to be removed should be the third one. It says less than 4 neighbors. Resize the window so I can see the samples at the same time. Seems to be working fine. some reason, looking at this, I thought I did not see the area being updated. You be careful with that and go. So if you don't use a pointer, if you just had area AOC.area instead of area star AOC.area, any changes it would pass the whole data to the function instead of just a pointer. And verifying that this is actually changing the data. S64, that's the @ symbol. With the volume set as a period, which is 46, so I think that confused me here, and I thought it was not getting updated. A little more debugging. Oh, yep, that's 46. Look at the correct index, yeah, 64. And I set it to 46. So it's working. Go back to the color, and yet it was still shows it's changed. The end of the function, check my count, 30. Sounds about right. And now I think is when I see the problem. I'm not calling remove TP anymore after the loop starts. So we just call that again. Oh, yep, find my second problem here. I say greater than or equal to for some reason. That's better. So I'll copy my answer for the puzzle input. 43 was the right answer for the sample. And we're done. Gotta wait for day 5 in 12 hours.